So let's look at this problem. So this problem is asking for all the subsets of a list. So if we look at this tree right here, let's say we started with 1, 2, 3. We'd want to return something that had 1, 2, 3, 1, 2, 1, 3, 2, 3, 2, 1, etc. Right? So every possible subset of this list should be in our result. So before we start the real solution, let's kind of exploit Python to do this for us, right? So let's do something like this. We'll have a result set, and then there is this method in itertools called combinations. And what it does is it returns all the subsets of a list of length I. So what we have to do is we have to do something like this. Result or equals the set combination of nums I, and then you return the result. So I went through this quickly, but pretty much all that's going on here is that this combinations function, which is in itertools, if you look at line 1 right here, it makes the subset of this list that's I elements long, right? So we want all possible subsets. So we're going to call it with every possible length from 0 to I. Okay, so that's kind of a way to do it that makes Python do the heavy lifting. But let's pretend that we didn't have that. So in that case, what we want to do is we want to build a tree that looks maybe something like this and traverse it. And at every node, we want to collect whatever that root node is. So for example, we store 1, 2, 3 in our return set. Then we create these 3 children nodes, 1, 2, 1, 3, 2, 3, and we store each one of them, and then we do everything recursively for its children. So in order to do this, it's really nice to have a helper function. So let's call it pluck. And pretty much all it's going to do is it's going to remove one element from this list at a time. So we remove, I guess, here to here we remove index I equals 2, and then here we remove index I equals 1, and then here we remove index I equals 0. So it's not quite in the right order, but hopefully you get the idea. And we're going to do that for every single element at every stage. And that's how we're going to have new leaves to recurse on. So that's what's going on right here. Okay, so now let's actually implement this function. So the first thing we should do is we should make a return set. And this is going to have all our solutions in it. Return set. And then let's go ahead and define a function that will run within subsets. So we'll say something like recurse. Its input is a list of nums. And let's go ahead and write it. So whenever you're doing something recursive, the first thing you should probably think about is your base case. So here, let's just terminate when our list of nums is empty. So when not list of nums return. And then we want to add whatever we have to our return set, right? So return set dot add list of nums. And let's convert it into a tuple. Let's do that explicitly. And the reason we're converting it into a tuple is because, first of all, tuples are hashable. Well, mostly tuples are hashable, so that's mostly why we care. So then let's do this whole recursive thing. So let's say for I in range len of list of nums, what we're going to do is we're going to pluck one element out at a time. So we'll say plucked list equals self.pluck list of nums, and then that particular index. So from there, we're going to do something like this. We're going to say if plucked list, oh, and remember it's actually a tuple if you look on line 60 right here, just for the record. Okay, so if plucked list is in our return set, we don't want to do anything. right? Because if it's already in there, I mean, what's kind of the point? We've already seen it at some point. There's no reason to recurse over it again. So let's just say continue. Continue. Otherwise, what do we want to do? We want to recurse on this plucked list. And that's pretty much it. Maybe if you want to make this a little more straightforward, we could say if plucked list not in return set, and then move this right here, and then we're done. So let's call recurse on our nums, and then return our return set. So just to go over it one more time, what's happening is we're initializing this empty set, and then we have this function called recurse that populates this return set over time. And the way it does that is every time you call it, it adds the root node into that return set, and then it iterates over that list, and it removes one element at a time, and then it calls itself again over that list with one element removed. And over time, this is going to give you something that looks like this. Cool.